So we have been talking about the earth retaining structures. In that chapter, we have already talked about rigid retaining structure, flexible retaining structures. As far as the flexible retaining structure is concerned, based on the materials used, based on the load, we have completed. Based on the materials used, the timber sheet pile walls, reinforced concrete sheet pile, steel sheet piles, braced cuts, all the things we have discussed before today lectures. So today we shall talk about the lateral earth pressure on seating or pressure diffusion behind seating. What does it mean? You can see this diagram, the braced cut diagram. Whenever you are going to provide the seating along the face of the excavated wall, along with the struts, which is called as braces, what is going to happen? The earth pressure is going to work on the seats, which may be timber seat or the reinforced concrete seat or the steel seat. So the pressure is going to work on the surface of the seats due to the earth. Horizontal pressure is going to work. So we shall talk about this topic. Rankins and Coulomb theory, we have already talked in earth pressure chapter to determine, to compute or to calculate to determine the earth pressures on the retaining wall. What it says that Rankine and Coulomb theories of earth pressures cannot be used for the computation of lateral earth pressure on seating, as those of theories are applicable to rigid retaining walls rotating at base. Rotating at base, in case of these theories are applicable for the rigid retaining wall, where the rotation is going to take place at the bottom of the retaining wall, that is at the base. Whereas in case of seating and bracing system, right, which are the flexible retaining structure, rotation takes place at the top of the wall. Okay, so you can see the first figure, braced cut, and how the deformation condition, rotation taking place on the top. This wall starts falling in the excavated area from the top, and how the pressure distribution diagram can be plotted behind the seating is also shown in figure C. Now, in earth pressure chapter, Rankins and Coulomb has given the pressure distribution diagram for the calculation of total pressures working on the retaining wall. Here, Peck has suggested that how we can calculate the earth pressures on the seating or on the seat placed in the excavated area. You can see here h is the height of the excavated area, and pressure distribution diagram. The Peck has plotted the pressure distribution diagram for the dry or moist sand. The pressure distribution is uniform with a pressure, active earth pressure, which is equal to 0.655 gamma HKA. At the bottom you can see gamma is the density of soil or unit weight of soil, H is the height of excavated area or the height of cut also you can say, gamma is the density. So once you know the pressure distribution diagram, you can calculate the total pressure working on the seating. Seating means the seat pile wall which has been installed along the surface of the excavated area. So 0.65 gamma HKA. K also you can calculate by the tan square 45 minus pi by 2. So how we can find out the total pressure working on this seat? How we can find out? 0.65 gamma HKA. This is the width and the height total H. We shall multiply we shall multiply the values, and then we can get the total pressure acting on the seat in case of dry or moist sand. So we completed this one, sub to medium clays. So pressure behind the seating we have completed. Now we shall see what are the different types of seating and bracing system. What does it mean? Whenever you are going to excavate the soil, I have already told you the usage of seat piles wall, where we can use. Again, we shall discuss in the last slides about this. What are the uses of the seat pile? Already I told you that suppose you want to excavate the area for the metro. In that case also you have to go for the seating and bracing. Seating means you have to provide either a steel seat or the reinforced concrete seat or the timber seat, right? And then you have to provide the support also, which is called a strut or wells. The struts are nothing but bracing. Seating and bracing means the use of seats with the bracing facilities, right? Bracing means the support system. Bracing is nothing but the support. We shall see here the following types of seating and bracing systems for braced cuts are commonly used. Braced cuts you can provide for the metro also. You can for the trenches also. For if you want to lay down the pipelines, there also excavation is required, and to stop the soil so that it will not fall in the excavated area. For that we can go for the seating and bracing systems. So what are the various types of seating and bracing system? You can see vertical timber seating. In this method, vertical timber seat piles about 8 to 10 centimeter thick are driven around the boundary of a proposed excavation. Suppose you want to excavate the soil in the form of a drain or for laying the pipeline. What we shall do? We shall drive the timber seat on one side, and on the another side we shall also drive the timber seat. So after driving in between the two seats, whatever the soil is there, we shall start the excavation, right? And the timber will also go parallelly inside the earth, and excavation is also carried out. That's why it is written there. Vertical timber seating about 8 to 10 centimeter thick are driven around the boundary of a proposed excavation to some depth below the base of the excavation. The soil between the seating is then excavated. This seating is suitable and economical for 4 to 6 meter depth maximum. In case of timber seating, the seating is held in place by system of wells and strut. You can see in the figure, the strut is also there. Timber seats has also been shown in the figure. Wells is also a support, right, which is the put or which is placed at the end of the strut, right. The wells are horizontal beams running parallel to the excavation wall, right. It is going parallel to the excavation wall along the timber seat. The wells are supported by horizontal straits, right, If the excavation are wide, the wells are supported by inclined strut known as rakers. Suppose the width of the excavated area is less. In that case, the strut and wells are sufficient. The seats are sufficient. But in case suppose the width of the excavated area is more, in that case we shall go for the support systems, which are called as rakers, right? So you can see the figure B, where how the rakers are provided in the excavated area to support the soil. The next is called a steel seat pile. In this method, the steel seat piles are driven along the sides of the proposed excavation. The same thing as we have seen in the timber seat pile. In this case also, we have to drive the steel sheets, where we have to go for the bridge cut, or where we have to go for the excavations or cutting. As this wall is excavated from the enclosures, wells and struts are placed. As you will start excavating from the top, you have already driven your steel sheets along both the sides of the excavated part, or the excavation part, right? And as you are going to start the excavations, parallelly you have to start putting the wells and struts so that the soil will remain stable, right? The wells are made up of steel. The struts may be made up of steel or wood. As the excavation progresses, another set of wells and struts are inserted. As we shall go inside the earth, or we can say as the excavation will be deeper, we can provide the other sets of the struts and wells. Now we can see the another types of seating systems are there, bracing and seating system, which is called a soldier beam. This is also one of the seating and bracing system methods. In this case, what we are going to do, we are going to use the H piles. H piles is nothing but the steel H piles. Already I told you in case of pile foundation, the railway sleepers, right? Railway steel sleepers, railway steel sleepers in the form of a H shape or H piles also. So what we can do here, that is also driven at the spacing of 1.5 to 2.5 meter around the boundary of the proposed excavations. As the excavation proceeds, horizontal timber planks called lagging are placed between the soldier beams. You can see the figure. The wells are there, starts joint J. The details of the joint J is also shown on the left side of the figure A. Lagging well, how the different components of the joints are placed to each other, you can see in the figure. The next is called as tie back. In this case, what we can do, you can see here in the form of the bracing in the form of struts or inclined rakers is provided. What we shall do, we are not going to use the strut or the wells here. Simply we shall make a hole inside the wall, right? And then we shall put the soldier beam, and inside the hole we shall put the concrete. Tendon means the rods, the steels we can say. We shall make it in the form of a bale, right? And then we shall fill the concrete so that the soldier beam will remain stable, and the lagging is also there. Hence, what benefit is there? Hence, there is no hindrance to the construction activity to be carried out inside the excavated area, because you are not going to use the strut or wells, right? So hindrance is not there inside the excavated area because the support is provided, right? A anchored seat pile one we can say, right? Inclined holes are drilled into the soil, and tensile reinforcement is inserted, and the hole is concreted. So this you can see the excavated wall is supported by the soldier beam and lagging. So what we talked about the seating and bracing system, that means how for the excavated area we can protect the walls of the excavated area by seating and bracing system so that it will not fall in the excavation zone. Otherwise, the construction work will suffer. The next topic, usage of seat pile. This is also given in your syllabus. So what are the uses? Seat pile walls are also the retaining walls constructed to retain the earth, water and any other fill materials like rigid wall, and it is used for various purposes. Waterfront structures such as wharf and quays. What is wharf? Wharf is nothing but it is a platform built at the shore into the water and supported by piles provided access to the ships and boats. That is called a waterfront structures, wharfs and quays. Next, in building diversion dams such as coffer dam, the seating and bracing system, or we can say the seat piles, which may be the either timber seat piles, reinforced concrete seat pile, or steel seat piles that can be used as uh, a coffer dams, right? In building diversion dams, so that you can make the area dry inside the water for the construction purpose. We can also divert the water from one drain to the other drain using the seat piles. This is also possible. For river bank protection, if you are going to uh, put the seat piles along the bank of a river, the erosion will not take place. For retaining the sides of the cuts made in earth, as we discussed in the previous slides, in case of bracing and seating system, also we can use the seat piles. And then beach erosion protections. So then next one, the stabilizing ground slopes. That means what? If you are going to provide this seating system, the landslide will not take place. The slope will also remain stable. So this is all about the earth retaining structures. So I think I have taken 3 lectures on the topic earth retaining structures. So your chapter earth retaining structure is completed now, and what we can see that the unit 4, which consists of 2 parts, one is the well foundation and another is the retaining walls, have been completed now. So in the next lecture we shall start from the unit 5. Thank you very much.